Hello everybody, my name is Rishikesh and today I will be discussing about the topics that the experiment that we have done in the last lab. The topic of the experiment is study of application of autocorrelation function for analysis of signals. The objective of the experiment is that to compute pulse rate from a PPG signal and pitch period of a speech signal using autocorrelation function in real-time Arduino prototype platform. So first objective is that for a free PG signal, we have to assume a sample rate of 100 Hz and resolution of 10 bit and frame duration of 5 seconds to compute the pulse rate from a PPG signal. And the second objective is that for a speech signal, assume sampling rate of 8000 Hz and resolution of 10 bit and frame duration of 30 milliseconds to compute the pitch period of the speech signal. So before we get into the details of the experiment, let us know what is autocorrelation. Autocorrelation, also known as serial correlation, is a delayed copy of itself as a function of delay. Informally, it is a similarity between observations as a function of the time lag between them. The analysis of autocorrelation is a mathematical tool for finding repeating patterns, such as the presence of a periodic signal obscured by noise or identifying the missing fundamental frequencies in a signal implied by its harmonic frequency. It is often used in signal processing for analyzing functions or series of values such as time domain signals. So this is autocorrelation. Now let us get into the procedure of the experiment. The procedure, these are the steps to be followed while carrying out the experiment. The procedures are we have to first compute autocorrelation function for each frame with a specific frame duration by using the following expression. We can say this expression, this is the autocorrelation expression. So the second expression is we have to find the maximum amplitude of autocorrelation function and its location from a first zero crossing point as by the following procedure. First, you have to compute location of the first zero crossing point of the autocorrelation sequence. Construct a window having the autocorrelation function values from the first zero crossing point. Then we have to compute maximum value of a window and also obtain its maximum location, that is the Lmax. Compute the maximum amplitude location as given below. We have to Lmax is equal to first zero crossing point plus Lmax. Lmax 1 is equal to first zero crossing point plus Lmax. Then you have to compute a period of a signal as given below. Period is equal to Lmax by Fs. Then you have to display the period of PPG signal for each frame. Store the estimated period of a PPG signal for 1 minute. So now let us look at the code. So I have taken 2000 samples of the input signal. These are the initializations that I have done. So now let us look this. First we have to filter the signal using the moving average filter to remove the noises in the PPG signal. First we have taken a 10-point moving average filter. So now then we have divided the 2000 samples into 4 groups, that is from 0 to 500, then 500 to 1000, 1000 to 1500, 1500 to 2000. So in each window we will be computing the pulse rate. So now we are computing, that means we will get 4 pulse rates. So for each window we have to find the mean of the values, and we have to subtract the mean from each value, so that to get because mean does not give us any information. So now this code will find the mean of the signal in each window. Then here we'll be subtracting the mean. In this we are subtracting the mean. Then we are computing the autocorrelation that we have seen in the PPT. Autocorrelation is x of n into x of n plus 1 and divided by r of 0. This is the maximum value, so we are computing the maximum value in this over here. M is the maximum value, so this is the maximum value, and here we are computing the autocorrelation. Then we are computing the pitch. Then after the autocorrelation, we have finding the local max, the zero crossing point and the local maxima. Then we are finding out the pitch pulse rate of the PPG signal. So now let us run this code. So now let us see the pulse rate of each window. So we can see that the pulse rate is 68.18 for the first window, 65.93 in the second window, 61.22 in the third window, and 66.67 in the fourth window. So they are nearly close to 60, and they all we can see that in all the four windows the values are close to each other. So this we have completed the first objective of our experiment. Now let us check what is the second objective. The second objective is for each signal we have to assume a sampling rate 8000 Hz and resolution of 10 bit and frame duration of 30 millisecond to compute the pitch period of the signal. So we have to follow the same procedure for this objective, but let us, before going there, let us know what is speed signal and pitch period. Speed signal. Speed signal is created at the vocal cords, which travels to the vocal tract and produced at speaker's mouth. So that this signal is traveled and reaches the receivers here. So now pitch period is, the pitch is a fundamental frequency of the vocal cord vibration. This is the fundamental frequency at which the vocal cord vibrates. So now let us look at the Arduino code for this. So I have not taken my own voice signal from Audacity software, and we have taken 2000 samples of the voice signal, and this is the initialization we have taken. We have taken the sample size 8000. Then we have followed the same procedure. We have removed the noise by using 10-point moving average filter. Then we have divided the signal into four parts, and then we have taken the average of each window. Then we have subtracted the mean from each value, and then we have computed the autocorrelation function. And this is the code for autocorrelation function. This is the M is the maximum value, and AUT is the autocorrelation array. Then we have found that the zero crossing point and local maxima from next local maxima. Then we have computed the pitch period of the signal. So now let us pitch period of the speed signal. So let us run this code. Now we can see that for the first window we have got 135.59, second window 131.15, 129.03, and the last window we have a 135.59. So this is the pitch period of the signal that I have taken. So that's it from this experiment. Thank you.